This video is to catch you up if you were absent on Friday, March the 8th. The first thing that I want to explain is the bell ringer. The bell ringer says write 625 in exponential form with a base of 5. The first thing that we need to understand is what is exponential form. If you have a number b with the power p, this number is exponential form. B is what we refer to as the base. P is the power or exponent. So we want to rewrite the number 625 so that it looks like this. Our problem states that we want the base to be 5. So let's go ahead and take our b off and change that to a 5. So what we need to know is, what does the number p have to be in order for the expression to equal 625? You can use your calculator to see that 5 times 5 is equal to 25. And then if you multiply that times 5 again, you get 125. And then if you multiply it times 5 again, you get 625, which is the number that we want. So how many times did we have to multiply 5 times our result to get to 625? Let's count. 1, 2, 3, 4. So 625 is equal to 5 to the 4th power. And if you want to verify that, you can type in your calculator 5 to the 4th power and see that it equals 625. For today's lesson, we are going to learn all about logarithms. So on a blank sheet of paper, make yourself 8 sections to take notes and work problems in. On the upper left section, we're going to make a note about exponential form. So let's remind ourselves what exponential form looks like. Exponential form is a number raised to a power. The number is called the base, and the small number is the power or exponent. Okay? Logarithms are the opposite of exponential functions. And they look like this. We read this as the log b of n is equal to p. Log is short for logarithm. Moving to your next square in the upper right, we're going to write again, log b of n is equal to p. So if we want to change this into exponential form, I have a little trick that I like to do to help me remember the correct order of writing the numbers. What I do is I take and make a circle starting at B through P, and I point to N. And that is the order that you'll write the numbers when you write an exponential. You'll write B to the P is equal to N. So we follow starting at B, going through P, and ending at N. Okay, let's practice taking this logarithmic form and writing it in exponential form. So first, let's make our circle. We're going to start at the 7, go through the 2, and point at the 49. So that means we have 7 to the second is equal to 49. Okay, here's another example for you. Now remember, step 1 is to draw the circle to help you keep the numbers in order. Start at the little number, go through the 5, and point back at the 32, and it makes a circle. So in exponential form, this number would be 2 to the 5th equals 32. Okay, pause the video and try to do this one on your own. And remember, it's just a pattern. You just need to keep the numbers in order. Never mind that this one has a fraction. It's just a number like any other. So pause the video and see if you get it correct. Okay, so we're going to start out by drawing our circle so we keep our numbers in the proper order. So here we're going to have 8 to the 1/3 power is equal to 2. So in a similar fashion as not writing x to the first or putting a 2 for the index of square roots, we have a common log with a base of 10 that we do not write the base. So if you see something like this, then it can be written without the base. So if we had this number, how would we write this in exponential form? Pause the video and remember that the base, if it is not written, is equal to 10, and see if you get it correct. So the exponential form of this number, let's go ahead and write in our base 10 here because it is actually there even though we don't write it, and we'll draw our helpful circle. So what we have is 10 to the 3rd power equals 1,000. Sometimes we're going to start in exponential form and we need to change it to logarithmic form. So once again, we're going to use the circle trick, and what we're going to do this time is we're going to draw a circle through the big numbers and point to the little. And then we're going to write those numbers in that order on a logarithmic form. So what we'll have is the log of b of n is equal to p. So if we had this exponential form and we wanted to make it logarithmic, draw a circle through your bigs and point to your little, and our logarithmic form would be log base 8 of 1 is equal to 0. Pause the video here and change this exponential form to a logarithmic, and then restart the video to check your answer. So what we should have done was make us a circle through the big numbers and point to the little, and then we can easily see that log base 5 of 25 is equal to 2. Write this problem down and pause the video and see if you get this next one right. Change this one to logarithmic form. Okay, so making our circle, go through our big numbers and point back to our little. Now remember, just because this one has a fraction in it doesn't make it any less of a number. We're still going to put it in the same spot as if it was a whole number. So it's going to look like this. The log base 3 of 1 over 81 is equal to -4. Next, we are going to learn how to evaluate logarithms. So if we're given a log and we need to evaluate it, the first thing that I want you to do is set it equal to x. Just like this. Log base 6 of 36 is equal to x. Now this puts it in a form that looks familiar to us, and we can use the little trick that I showed you, starting at the little number, going through this side and pointing back at this one to change this to exponential form. So exponentially this is going to look like 6 to the x is equal to 36. So if you remember, our bell ringer looked similar to this. So what we want to do is put the 36 on a base of 6. So let's rewrite it as 6 to the x is equal to 6 to what power? I'm just going to put a blank there for us to fill in the power. So you can go to your calculator and start typing in 6 times 6 and see how many times you have to do that until you reach 36. But right away we can see that 6 times 6 is equal to 36, so that means just twice. So 6 squared equals 36. So let's go ahead and take this 2 and put it over here. Okay, the next note that I want you to write is, if 2 numbers are equal and their bases are equal, so are their exponents. So what that means is, if this entire number is equal to this entire number and the base here is equal to the base here, then this number here has to be this number here. So following that, we know that x is equal to 2. Now let's practice evaluating some logarithms. So if we want to evaluate log base 2 of 128, our first step is to set it equal to x. Then let's use our trick to draw a line through the 2, the x, and point to the 128. So now we can write it in exponential form. 2 to the x is equal to 128. Okay, so now we know that 2 to some power is equal to 128. So we have to figure out the power that goes right here. So you can get out your calculator and start typing in 2 times 2 times 2, and we know that is 8. So if we multiply 8 times 2, we get 16 times 2 again, and we get 32 times 2 again, and we get 64 times 2 again, and we get 128. So how many times did I have to multiply times 2? Well, let's count them. 1, 2, 3, 4, 5, 6, 7. So that means that 2 to the 7th is equal to 128. So what I have is 2 to the x is equal to 2 to the 7th. So since these two numbers are equal and my bases are both 2, that means that x has to be 7. So we can write x is equal to 7. Pause the video here and try to work this one on your own. Okay, so the first step you should have taken was to set this equal to x. Okay, now let's draw our circle to help us keep our numbers in order. So that tells us that we should have 4 to x is equal to 256. So what we want to know is, what is the power that I have to put here in order to achieve 256? So you can go to your calculator and start typing in 4 times 4 and see how many times you have to do that in order to get 256. Okay, let's count. So I have 1, 2, 3, 4. So that means that this number that goes right here is 4. So our x equals 4.